Very good afternoon, students. Welcome to the SBR online classes. Uh, so, as you know, yesterday we have started the chapter Permutation and Combinations. Yesterday we did one of the basic concept, that is fundamental principle of counting. We finished one of the exercise there, first exercise 7.1. Now, to deal with the 7.2 exercise problems, we have to know about again one of the basic concept here, that is factorial notation, right? If you know this factorial notation, you can solve the second exercise problems. All the problems are very easy in the second exercise here, right? Just see here what it is. Factorial notation. What is factorial notation? The notation n factorial, right, represents the product of first n natural numbers, students. The product of first n natural numbers, right? What are the natural numbers? Natural numbers, naturally occurred numbers, known as natural numbers. What are the natural numbers now? Starting from 1, 1, 2, 3, 4, so on up to n. So all are what here? Natural numbers. So if you do the product of those things, the product of first n natural numbers, you'll be getting what here? N factorial. We denote it as like this, n exclamation mark. This is nothing but what here? We read it as n factorial or factorial n. And also in another way you can denote this. In this way also it is denoted here, in this way or another way, like this. So both are what here? Both are same. It is read as what here now? N factorial or factorial n. What it is actually? Product of first n natural numbers, that is 1 into 2 into 3 into so on up to n, right? So now you see this, for example, let me take 3 factorial, students. How do you write 3 factorial? It's a product of first 3 natural numbers, 1 into 2 into 3, right? So can I write this as like this, students? 2 into 3 into 1, right? We'll be getting the same answer. The same answer as what here? 6. 1 into 2, 2. 2, 3 is a 6. Here, 3, 2 is a 6. 6, 1 is 6. Both answer you are getting same here. I can express 1 into 2 into 3 as 3 into 2 into 1. Yes or no? So in the same sense, n factorial is, we know now. What is n factorial here? N factorial is 1 into 2 into 3 into so on up to n minus 1 into n, right? I can express n factorial in this way also, students. n minus 1, n minus 2, so on up to 3 into 2 into 1. Got it now? So writing in this way, 1 into 2 into 3 into so on up to n minus 1 into n is same as n into n minus 1 into so on up to 3 into 2 into 1. Got it now? So this is the way, right? So if you express in this way, right, it is same as this one here. And while dealing with the problems, just express in the descending way, students, right? Why? Because it is easy to get the answer there. That's why we refer in this way now. N factorial can be written as what now? N into n minus 1 into n minus 2 into n minus 3, so on up to 3 into 2 into 1, at last 1. Or else you can write 1 into 2 into 2, so on up to n there, no problem. So now you see, how do I express now 5 factorial, students? Now according to this, 5 into 4 into 3 into 2 into 1. Got it now? In the descending way I'm writing it. It is also, of course, it is a product of first 5 natural numbers. It is nothing but what here? 5 factorial. Got it now? So why we write like this? Because there are some of the examples they'll be providing like this here. 5 factorial divided by 3 factorial, right? So looking to the denominator, I can express this. Looking to the denominator, students, where it had gone, 1 second. Okay, looking to the denominator, students, looking to the denominator, I can write this. Sorry. Okay, no problem, students. Let me write here. So 5 factorial, we arrive some of the situation like this: 5 factorial divided by 3 factorial. So I can write 5 factorial as what here? 5 into 4 into 3 factorial. I'll be stopping here. Why? Because looking to the denominator, students, right? So looking to the denominator, I can stop here, right? So what is the answer now? 20. 5 4 is a 20, right? So that's why we express the n factorial in the form of in descending way, the product of first n natural numbers in descending way. If you write, it is well and good to get the answer easily there, right? So that's why we refer in the descending way, students. Got it now? Now, after knowing all these things, right? After knowing n factorial as n into n minus 1 into n minus 2 into so on up to 3 into 2 into 1, right? 3 into 2 into 1. So now I can express this also as in this way: n into n minus 1 factorial. I can write this also, right? If you split again, it becomes n minus 2, n minus 3, so on up to 3 to 1 there. And I can write n factorial as n into n minus 1 into n minus 2 factorial also. 2 factorial also there, right? According to the situation, I can express n factorial in this way, students. Got it now? Just remember this. This is the factorial notation, what we discussed here now, right? So, and also, along with this, we define what, students, here? We define 0 factorial as 1. In the factorial notation, we define 0 factorial as 1. Just remember this one here, right? If you know these two things, n factorial formula and 0 factorial is 1, we can solve the second exercise problems, students. All problems are very easy in the second exercise problems. If you know the multiplication, you can solve throughout the second exercise problem, students, here, right? 1 second, students. Sorry for the inconvenience, students, here. So now here we are dealing with the factorial notation. Let me do the second exercise problem, students. Second exercise problems, let us do, students, here. Evaluate 8 factorial. Now you know the factorial notation, right? Now let me solve this one, students. It is very easy, simple one, right? The first one, let me solve the 8 factorial. Just I told you how to express 8 factorial, students. Now 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1. Yes or no? So n 8 factorial is nothing but what here? It's a product of first 8 natural numbers. Got it now? So just multiply, students, here. What do you get? What do you get? 1 2 is a 2, 2 3 is a 6, 6 4 is a 24, 24 5 is a 120, 126 is a 720, 727 is a 727 is a 5020, right? 5040, 5040 into 8, 5040 into 8, what do you get? 5040 into 8, you'll be getting 40320, students, right? 8 4 32, 320, and 8 5 is 40, 40320. 8 factorial value will be getting what here? 40320, right? In the same sense, what is second value, students, here? What is second they have given here? We have to evaluate 4 factorial minus 3 factorial. So now you should not write 4 factorial minus 3 factorial as 1 factorial. It is wrong, right? Firstly, we have to simplify this 4 factorial first. What is 4 factorial, students, now? 4 into 3 into 2 into 1. Got it? Minus, write down minus as it is. 3 factorial, how do you express? 3 into 2 into 1. Yes or no? Right? So what happens now? What is 4 into 3 into 2 into 1? It's a 24. 24 minus 3 into 2 is 6. So 24 minus 6 will be what here? 18. So 4 factorial minus 3 factorial is not 1 factorial. It is how much here? 18. Got it now? Understood this? So this is the first problem of the second exercise here. It is a very simple one. Let me go with the next problem, students. Second problem. So what second problem says here? Is 3 factorial plus 4 factorial is equal to 7 factorial? Whether it is true, let us verify it. Right? Just see. So now let me consider the LHS first. What is LHS, students? 3 factorial plus 4 factorial here. What is 3 factorial can be written here? 3 into 2 into 1 plus 4 factorial. How do we express, students? 4 into 3 into 2 into 1. So what is 3 into 2 into 1? It is 6. 4 into 3 into 2 into 1. It is what here? 6 4 0 24. Got it? So add it now. What do you get? 30. You are getting what here? 30. LHS, how much you got? 30. Let me call it as equation 1, friends. So 3 factorial plus 4 factorial, how much you got? 30 as the answer here. Now let me go with the RHS here. What is the RHS, students? What they have given RHS? 7 factorial. How do you express 7 factorial? 7 into 6 into 5 into 4 into 3 into 2 into 1. Right? As you know, 4 factorial is 24, 24 5 is 120, 126 is 720, 720 into 7. It's a 5040. Right? 720 into 7 is how much here? 5040. So this is the RHS we got. Whether, check it out, whether LHS is same as RHS, students. LHS is nothing but what area? 3 factorial plus 4 factorial value is 30 and 7 factorial value is 5040. Whether both are same? No. No means what here? What we should say here? Sorry. From 192, I can say that 3 factorial plus 4 factorial is not equal to 7 factorial. Got it now? Understood this? Simple one, right? Just we have to verify it. Let me go with the third problem, students. Again, it is a simple one. Compute. We have to compute the one of the quantity here. What is the quantity here? 8 factorial divided by 6 factorial into 2 factorial, right? So given thing, first you write down the given quantity, students. 8 factorial divided by 6 factorial into 2 factorial. So while writing in the descending way, students, I told you, looking to the denominator, we have to modify this numerator here, students. 8 factorial. 8 factorial can be written as 8 into 7 into 6 factorial I'll be writing here. Why? Why? Because looking to the denominator, to cancel it, I'll be stopping here itself. I can multiply further thing. I can write further elements also. But here we'll be getting cancelling directly here. For that purpose, I'll be keeping as it is here, right? To save the time, I'll be keeping as it is like this here, 6 factorial. So denominator is what here, 6 factorial as it is. To cancel it, I'll be writing like this. Now, sorry. So 8 factorial is written as 8 into 7 into 6 factorial. 6 factorial, let us keep as it is. And 2 factorial is written as 2 into 1. Now you see, 6 factorial get cancelled, students. So 2 ones are 2 fours are. So what happens now? 4 sevens are 28. So this is the answer. Simple one, right? Normal multiplication, you have to do it. Let me go with the next problem, students. Fifth one. Fifth one, it is an important one for 2 marks, students. Right? For 2 mark, it is very much important one here. So what they have given? We have to find x if the equation is, what is the equation here? 1 by 6 factorial plus 1 by 7 factorial is equal to x divided by 8 factorial. This is also a very easier one, but important one. Okay, just see. Consider given thing here. What they have provided? Given 1 by 6 factorial plus 1 by 7 factorial is equal to x divided by 8 factorial. Got it now? Again, students, while dealing with the problems, right? See which one is the least factorial. Least factorial is 6 factorial, right? Just keep as it is. Do not disturb that one here. Keep the 6 factorial as it is. Now you can split the further greater factorial terms there, right? What are the greater factorial terms above than this 6 factorial here? 7 factorial and 8 factorial. You have to split those things here, right? Now 1 by 6 factorial. It is the least quantity. I have to keep as it is. Now 7 factorial. How do I write 7 factorial now, students here? 7 into 6 factorial. Knowing the least factorial, I'll be expressing 7 factorial as 7 into 6 factorial. In the same way, in RHS side also, x divided by 8 factorial. How do I express? 8 into 7 into 6 factorial, right? Looking to the least factorial, I'll be splitting 8 factorial as 8 into 7 into 6. Now you see, students, in LHS side, it is sum of two terms, a plus b. Yes or no? In these two terms, what is common thing here? What is the common term here? 1 by 6 factorial. Here also we have 1 by 6 factorial. In these two things, I have the common term as 1 by 6 factorial. Take the 1 by 6 factorial common outside here, right? I'll be taking common term outside here. What I'm getting here in this place? 1 plus 1 by 6 factorial into 1 by 6 factorial. Next, plus 1 by 6 factorial I took outside here. What remains? 1 by 7 remains. Got it? Now you see, x divided by, let me keep as it is. Do not disturb this. 8 into 7 into 6 factorial. Now you see, students, here what get cancels here? What get cancels? 1 by 6 factorial. Here also 1 divided by 6 factorial. There is no 1 here, means x into 1 there, right? 1 by 6 factorial. Here 1 by 6 factorial. Here 1 by 6 factorial get cancels. Got it now? So here the bracket is there, the sum of two terms, right? Now let me take the LCM in this bracket. Take the LCM, students. Here nothing but what here? 1. Yes or no? Take the LCM. 1 7 is 7, right? So now cross multiply here, or 1 how much is 7? 7 is multiply it. 1 7 is 7 plus 7 how much is 7? 1 is. So multiply 1 there. 1 into 1 is 1 again. So here x divided by 8 into 7. Let me keep as it is. 8 into 7. Now you see, students, what happens, right? Now you see what happens here. Uh, 8 divided by 7. 8 divided by it is 7 there, right? 8 divided by 7 remains here. X divided by 8 into 7. Now cross multiply this to the LHS side. 8 by 7, it is already in the LHS side. Now what I'm doing here, I'm cross multiplying to the LHS side here. It becomes 8 into 7, students, right? I'm cross multiplying it. What happens here in the, what remains in the RHS side? X remains. See what cancels? 7 cancels, students. So 8 8s are how much, students, here? 8 8s are 64. Simple, right? Right? 8 8s are 64. This is the answer, right? So what I have done, let me recall here. What I have done, let me recall here. So given thing I have written here, given equation I have written. See which one is the least factorial. So that least factorial I should keep as it is. Further things I have to split it. 7 is there. 7 I'm writing it as 7 into 6. 8 factorial they have given. I'll be expressing it as 8 into 7 into 6. Right? In the first two terms in the LHS side, 1 by 6 factorial is common. If you take outside, what remains here? 1 plus here, 1 by 7 remains here. Keep RHS term as it is there. Here 6 factorial get cancels, looking both the sides here. And I took LCM in the bracket here. What is LCM? 7. Cross multiply here, 7 plus 1. Right? Here RHS I kept as it is. What are the remaining terms? X divided by 8 into 7. These are the remaining terms there. Again, 7 plus 1 is 8. 8 by 7 I have written here. Right? 8 plus 7 I have written here. Sorry, 7 plus 1 is 8. 8 by 7 I have written. Same RHS term as it is. What I have done, I cross multiplied to the left hand side this denominator term of RHS side. So when I cross multiply, here 7 7 get cancels. 8 8 is a 64. That is the X value. Simple, right? But important one, students. Important one for the exam point of view for 2 marks here. Okay. Let us go with the fifth problem, students. It is a simple one again. They have given one of the quantity. Evaluate the quantity. Which quantity? N factorial divided by n minus r factorial when n is 6, r is 2. The first case. Suppose if n is 9 and r is 5, then what will be the value of this quantity here? Right? So, for the two cases, I have to find the value of the given quantity here. So now, let me do the first one. First one, let me do first one. When n is 6, r is 2, right? When n is 6 and r is 2, then the quantity, then the quantity n factorial divided by n minus r factorial will be, what happens now? What is n now, students, here? 6 factorial, right? Got it? Bracket, n is 6, minus is a red one, minus r is how much here? 2. 2 factorial. Got it now? So is equal to 6 factorial as it is. What is 6 minus 2? It is 4. 4 factorial. Looking to the denominator, students, I'll be splitting the numerator here. 6 factorial, I'll be expressing it as 6 into 5 into 4. Right? 6 into 5 into 4. Divide by what here? 4 factorial. To cancel this, I have stopped here. So this 4 factorial get cancelled, students, here. What happens? 6 5 it is 5. 6 5 6 5 30. Got it? 6 5 30. So this is the value of n factorial divided by n minus r factorial whenever it is, right, when x is 6, r is 2, this quantity is how much here now? 30. In the same sense, whenever n is 9 and r is 5, then what will be the value of this quantity? What is the value of this quantity? Let us find out now. First, this is the first case. Just take down this. Let me do the second one, students, here. Let me do the second one now. Second case. What is the second case here? When n is 9, r is 5. Second case. When n is 9, r is 5. The second case, right? So then substitute these two things in the given quantity. What they have given thing here? N factorial divided by n minus r factorial. They have provided this. We have to substitute here all these things here. N is how much now? 9 factorial, students. And 9 minus 5. 9 minus 5. So what is 9 factorial now? 9 factorial, 9 factorial, let us keep as it is here, students. Right? So 9 factorial as it is. What is 9 minus 5? It is a 4 factorial, right? 4 factorial. So now what happens here? What happens? So let me split this 9 into 8 into 7 into, right? 6 into 5 into, I have to stop here itself. 4 factorial. Why? Looking to the denominator again. So 4 factorial get cancelled, students. Just multiply this quantity. How much you are getting here? 8 8 9s are 72. 8 9s are 72. 7 6 are 42 into 5, right? So multiply these two things. 72 into 5 2s are 10, 1 carries, 5 4s are 20, 20 into 1, 21 there. So again multiply these two things, students, here. 0 as it is here. 21 2s are 42, right? 21 2s are 42, 4 carry, right? 21 7s are 147. 147 plus 4, yes or no? 21 7s are 147 plus 4, 151. 151, right? 15120 is the answer, right? Got it, students? Just multiply the things, we'll be getting the answer. So this is what here, this is what the value of, right? This is the value of this quantity n factorial divided by n minus r factorial whenever whenever n is 9 and r is 5. Simply you substitute here, multiply the things, you'll be getting the answer 15120 there. Got it, students, now? Let us move on to the example problem, students. The second exercise is completed, but we have worked example problems in the second exercise there. So what are the worked example problems here? Simple. Example 5, right? Yesterday I did example 4. I gave 3 examples, first 3 examples as a homework there. Fourth one I did there. So fifth example, worked example problem now. First one 5 factorial, simple one here, right? First one 5 factorial, students, right? Simple. 5 4 3 2 1. So what do you get? It's a 120 is the answer, right? Split the things, you'll be getting the answer. 7 factorial, just keep it in the mind. 5 factorial value is 120, right? 7 factorial is 5040 in that way. 7 into, how do you express 7 factorial? 7 into 6 into 5 into 4 into 3 into 2 into 1, right? 5 factorial is 120. 120 into 6 is 720. 720 into 7, it's a 5040 value. After knowing these two values, students, 5 factorial is 120, I know here. 7 factorial is 5040, I know value. And what will be this one here, right? Third one. What is the third one, students? 7 factorial minus 5 factorial. Whether 7 factorial minus 5 factorial is 2 factorial? No, it's not, right? We did one of the problem in the exercise there. It won't be, right? So 7 factorial minus 5 factorial. 7 factorial, I got the answer. How much 7 factorial value is? 5040 minus 5 factorial we got here. How much it is? 120. So what happens now? Subtract here. 0, 4 minus 2 is 2. 40 minus 1, it is a, sorry, 50 minus 1 is 49, right? 4920 is the value of 7 factorial minus 5 factorial. Got it now? Simple one. Go for the next problem, next example problem, students, right? This is the next example here, worked example 6, right? First one. So we have to compute this 7 factorial divided by 5 factorial. So how do we express 7 factorial? Looking to the denominator now. What happens? 7 factorial is written as 7 into 6 into 5 factorial divided by 5 factorial. Yes or no? Here both things are same. Cancel it. What do you get? Multiply the things here. 7 6 42 is the answer. Right? Only multiplication, students, in this exercise. If you know the multiplication, second exercise is very much easy, right? Now, go for the second problem of this example 6. So what they have provided? 12 factorial divided by 10 factorial into 2 factorial. See what happens now? Looking to the denominator, let me simplify this numerator here. Here denominator is what here? 10 factorial. So up till there I'll be expressing the product here. 12 factorial is 12, 12 it can be written as 12 into 11 into 10 factorial. 12 factorial can be written as 12 into 11 into 10 factorial. Looking to the denominator here. So 10 factorial as it is, 2 factorial is written as 2 into 1. So these two things get cancels, right? Yes or no? So 2 ones are students, 2 6 are. So 6 into 11, 66. Divide by 1 as it is. So this is what here? This is the value of the given quantity 12 factorial by 10 factorial into 2 factorial. How much here? 66. Got it now? So simple one, students. Here you can pause the video and you can take down the notes there, right? So let me go with the next example 7, right? So same thing we did in the last problem of the second exercise there. So it is similar one. Let us do it. Solution. So given quantity n factorial divided by r factorial into n minus r factorial. When n is 5, r is 2. So what will be the value of this quantity whenever I substitute n as 5 and r as 2 in this? So when n is 5, r is 2, then the quantity n factorial divided by r factorial into n minus r factorial will be. See what happens, substitute n as 5 now. R as how much here? R value they have given 2 factorial, students, right? 2 factorial they have provided, bracket. N is 5 minus R is 2. Now simplify, simple one, right? 5 factorial, let us keep as it is. 2 factorial, what is 5 minus 2? 3 factorial. Looking to the denominator, I'll be expressing 5 factorial as 5 into 4 into 3 factorial, students. Divide by 2 factorial into 3 factorial. So 3 factorial get cancels, right? So 2 factorial is 2 now. Yes or no? Or how do you express this 2 factorial, students? Let me write once again here. 5 factorial is written as 5 into 4 into 3 factorial. So 2 factorial is how much here? 2 into 1, and 3 factorial is as it is. To get cancel here, I keep 3 factorial as it is here. So 3 factorial get cancels now. So 2 ones are, 2 twos are. So what happens here? 5 twos are 10. So total answer is how much, students, now? 10. So this is the value of the given quantity whenever n is okay. So whenever n is 5 and r is 2, the given quantity value is how much here? 10. Got it now? So let us move on with the next worked example problem, students. It is also important one. Similar problem we did in the exercise there. Again, it's an important one for 2 mark here, right? Again, important one for 2 mark here. So this is the equation they have provided. I have to find x here for the given equation there. So solution. What they have provided here? 1 by 8 factorial plus 1 by 9 factorial is equal to x divided by 10 factorial. This is the equation they have provided. I told you, students, to solve this problem, see which factorial term is least one here. Here 8 factorial is least one from all the 3 things there. So I have to keep 8 factorial as it is. Next, I have to split the product of other 2 factorial terms there, right? 8 factorial is the least one. Let me keep as it is, students. And 9 factorial plus 1 by 9 factorial. How do I express now? 9 into 8 factorial, knowing the least value there. Next, x as it is in the numerator of RHS side. 10 factorial. Again, I'll be expressing it as 10 into 9 into 8 factorial. Okay. Now, see the same thing we have to do, right? So what is common in these 2 terms here? It's a plus b form in the sum of 2 terms. What is common term here? 1 by 8 factorial is common term. Let me take 1 by 8 factorial as common thing. What remains here? In this place, it remains 1. 1 by 8 factorial I took common. 1 by 9 remains, students. Right? Here, let me keep RHS term as it is. Do not disturb this one here. See, students, what get cancels by looking to these 2 things now? looking to the equation now. So here 1 by 8 factorial, here 1 by 8 factorial get cancels. Yes or no? These two things get 8 factorial get cancels. You should not write here 10 factorial into 9 factorial into 8 factorial. No, it's wrong. So 10 factorial is written as 10 into 9 into 8. Only 8 factorial get cancels there, right? Here only 9 remains, not 9 factorial remains here. Got it now? 1 by 8 factorial, if you take common, only 1 remains. Here only 1 by 9 remains. Got it now? Here, let me take LCM students in this bracket after getting 8 factorial get cancels here. After cancelling this, take the LCM now. 9 as a LCM, yes or no? Here nothing but 1, 1 9 is a 9, 9 is the LCM. Now cross multiply students, 1 9 is a 9 plus 1 into 1 is 1. So 1 how much is a 9? 9 is a. So I have to multiply 9 to the numerator. Now 9 1 is a 9. 9 how much is a 9? 1. 1 into 1 is 1. Got it? So is equal to x divided by 10 into 9. Do not disturb this. 8 factorial already cancels there. So what is 9 plus 1? It is 10. 10 by 9 here is equal to x divided by 10 into 9. So next, what I do? Students, I cross multiply this 10 by 9 into, cross multiply this students here, 10 into 9 is equal to x. See what get cancels? 9 and get cancels. So what is the x value now? X value is 10 tens are 100. Got it now? Simple, right? For 2 marks, important one. Got it? Right? So see, they have provided this equation. Looking to the least factorial, I splitted this 9 factorial and 10 factorial there. I took 8 factorial common. What remains? 1 plus 1 by 9 remains in this bracket. RHS side I kept as it is. 8 factorial, 8 factorial I cancelled here. I took LCM in this. 9 is LCM. 9 plus 1 remains in the numerator. So what I've done? 9 plus 1 is 10. 10 by 9, right? X by RHS I kept as it is. Okay. So what I've done again? I cross multiplied this. Here 9 9 get cancels. X values are how much now? 10 tens are 100. 10 tens are 100 you got, right? So this is the value of x, students. Okay, so this is all about what here? This is all about this is all about second exercise problems here. No more problems are left out in the second exercise problems. So this completes second exercise problems. The first exercise problems are based on the fundamental principle of counting. We had two rules there: fundamental principle of multiplication, fundamental principle of addition there, right? So what is multiplication rule? If an event or a task occurs in m different ways, another event occurs in n different ways, then total number of events occurring together is m into n ways. That is the multiplication rule. Whereas addition rule, if one of the event is occurring in m different ways and another event is occurring in n different ways, then occurrence of the events, either one of them is given as m plus n. So based on those two rules, we did the first exercise problems yesterday, and today based on the factorial notation, right? Based on the n factorial for product of first n natural numbers. Based on the factorial notation, we did the problems there, and also we defined 0 factorial as 1. Just keep that in mind there, right? So this completes second exercise problems. So to move on the third exercise problem, students, we have to know about permutation. We have to know about permutation now. So what is permutation, students? Permutation is nothing but what here? Arrangement, right? Arrangement in order, right? Here order matters. In the permutation, order matters, students, here. right? Arrangement in order of number of objects taken some or all at a time, right? Arrangement in order of what here? Of number of objects, even given number of objects. What they will be providing some number of objects. I have to arrange them in a particular order there by taking some of the objects or by taking all of the objects there, right? For example, if I have uh, the four books here, PCMB, right? If I have PCMB four books, I have to arrange three books in the shelf here, right? I have to arrange three books in the shelf. So in what way I can arrange? There are four books, right? I have to arrange any three books in the shelf. In how many ways I can arrange here? Here I can keep here in the shelf, right? The first book I can keep as what here? Physics book, right? P. Next I can keep chemistry, then maths, right? Or else in this way I can arrange it by keeping first as physics, then maths, then chemistry. Or else I can keep first as physics, then what happens? I can arrange like this here. I can take biology book also there. I can arrange in this way. Any three book I have to arrange in the shelf there. Got it? So there are four books, but I am taking how many books? Only three books, and I am arranging them. So this is the arrangements here, right? So in another way, I can arrange this. Firstly, I'll be keeping physics, then biology, then chemistry there. Next, or else uh, then firstly I can keep chemistry book there, next physics book, then maths. This is one of the arrangement by taking any three books and arranging them, right? So now another way of arrangement, by keeping first chemistry book as it is here, I'll be shuffling this, right? Next, or else like this, I can take the biology book now, right? So next I can write I can shuffle in this way also there. This is one of the arrangements, right? Or else now you see students, by keeping the physics books there, right? Now I'll be keeping maths. I took all the three things there. Okay, no, sorry. Physics, biology. Next, now all possibilities got over now. Next, I can keep what here? Mathematics as a first book, students, right? Now I can keep the second book as a physics, then chemistry, or else in this way also. This is one of the arrangement here. This is also an arrangement. This is also another arrangement. So how many ways I can arrange? See here, physics, biology, right? Chemistry, right? Sorry, next, biology, physics. Next, keeping biology as the first one, keeping biology as the first book here, I can choose physics and maths, or in this way also arrangement I can do, right? Or physics, chemistry, I can take chemistry, physics I can do, right? Or I can take what here, students? Physics, maths, biology. In this way also I can arrange here, right? By keeping first as physics, then I can take mathematics, then biology there, or else biology, mathematics in other sense. So they again we can follow other things also there. Still 2 plus 2 plus 2, 6. Still 6 things we can arrange the things. Totally how many here? 4 plus 4, 8, 8, 12, 16, 16 plus 8, right? 16 plus 8, 24. In 24 ways, I can arrange any three books in the shelf, right? In 24 ways, I can arrange the three books in the shelf by taking four books there. Got it? So this is the arrangement. This is the arrangement process. Nothing but what here? Permutations we say. Here order matters, students. What order matter means? Firstly, I wish that the first book should be what here? Physics only there. Next book should be what here? Chemistry only. Next third book should be what here? Physics only. Or else I can wish that the first book, while keeping the math, should be there. Next physics, then chemistry. So in any other way. So total possibilities of arranging are how many students here? In 24 ways. So how it has come? How it has come 24? So directly, how do we know? So total 24 ways of arrangements we can do by this situation here, right? So we denote particular thing, students. We denote particular thing. Since how many objects we have here? Since we have 4 books, students, 4 objects we have to arrange them. 4 books, by taking 3 books, I have to arrange them. We denote in this way, right? From 4 different objects, we are arranging 3 objects at a time, students. So what is the value here? 24 we got. So how we got 24? By arranging this theoretically here, but formula will be there here. What is the formula, students? It is given as like this. The formula is given as 4 factorial divided by 4 minus 3 factorial. That is generally n out of n objects. If I wish to arrange r number of objects, it is given as n factorial divided by n minus r factorial, like this. Now you see, students, 4 factorial. 4 factorial divided by, what is 3 factorial? 3 minus 4 minus 3 factorial here? That is 1 factorial. So 4 factorial, 4 into 3 into 2 into 1 divided by 1 factorial. So how much you got? 24. So I told you. So in 24 ways, you can arrange the 3 books, right? Arrange the 3 books by taking any 3 books from the given 4 books there. Got it now? So this is the process, right? So for this process, we have one of the formula. Just you have to remember this. What is the formula, students? You have to remember here. This is the formula what I have written here. So let me write once again here. NPR is n factorial divided by n minus r factorial, students. So this is the formula you have to remember. That to what here? With the case without repetition. Without repetition. Right? So there are n objects. There are n number of objects. Out of n distinct objects, out of n out of n distinct objects, if you want to arrange r number of objects, we have this formula, students. That too without repetition. Repetition is not allowed. Got it now? Without repetition. Once you have chosen the physics book, means again another physics books you can't choose it. But here they have provided only one thing, no problem. But repetition should not be allowed here. Without repetition, the formula is given as what here? N factorial divided by n minus r factorial. Got it now? So how we got this? We got this formula with the help of fundamental principle of counting rule, right? With the help of FPC rule, the multiplication rule. With the help of multiplication rule only, we got this formula, students. Let me try to elaborate. Let me give you idea how we got this formula there, right? Now you see, students, here I have n distinct objects. N distinct objects as 1, 2, 3, 4, 5, 6, so on up to n distinct objects I have, and I have r number of boxes. R number of boxes, right? So now out of n distinct objects, I have to arrange r number of boxes, where r lies between 0 to n. right? You can R lies between, and at least one you have to arrange them, right? At least one you have to arrange it. Got it? So R lies from what here? 0 to n, where 0 is not included. At least one you have to arrange them, right? So out of n distinct objects, here I wish that R objects I have to arrange them, right? R may be what here? R may be 6, R may be 3, R may be 100, right? Got it now? There are n number of objects, different objects. I have to arrange only R number of objects. First box, second box, third box, fourth box, so now to rth box. Now you see, by the FPC rule, how do we are doing this? How do we are dealing with this now, right? What FPC rule? We did some of the problems in the first exercise. You see, students, using this five numbers, I have to form 3-digit number, right? 3-digit number without repetition. How do you are dealing there? Here in the first box, you are filling what here? 5 ways. Here in the first box, I can fill either 1 or 2 or 3 or 4 or 5. In how many ways you can fill the first box here? In 5 ways. Since it is without repetition, the next box can be filled in 4 ways, right? How? If I filled one of the element in the first vacant place, still how many are remaining there? One decreases there. That's in 4 ways I can fill the second vacant place. Similarly here, once I filled the number 5 in the second vacant place, still how many are left out to fill the third vacant place? 3. So by the FPC rule, what we are dealing here? What we are dealing here? 5 into 4 into 3, right? 5 into 4 into 3. This is the FPC rule. Now you see, students, in the same sense, what we have, just here, students, in the same sense, what we have, students, now here, instead of 5 numbers, we have n numbers here. And here, instead of forming 3-digit number, here we have to form what here? R number of things, right? Here, R number of things, I have to arrange them. And form means arranging here, right? So now, in first box, in how many ways I can fill? In the first box, I can fill in n ways, students. Here, the first vacant place, either I can fill number 1 or 2 or 3 or 4 or 5 or so on up to n. So in the same sense, I'm dealing here. In the first vacant place, I can fill the n ways here. Now you see, in the second vacant place, suppose once if I have filled one of the number in the first vacant place, still how many are remaining here in the objects here? Still how many are remaining? N minus 1 objects are remaining. In how many ways you can fill in this second vacant place now? N minus 1. Got it now? Next, suppose if I have filled number 4 in the second vacant place, still how many are left out? Out of n objects, I have substituted 2 elements already here. Still how many are left out now? N minus 2. So from the n minus 2 terms, how many you can fill here? How many possible ways you can fill? N minus 2 ways. Either you can fill 1 or 2 or 3 or 5 or so on up to n values. So in how many ways you can fill? N minus 2. In the same sense, next will be what here? N minus 3. Now you see, what would be the value can be filled in this rth box, rth vacant place? Here we can fill n minus of r minus 1. How? Because just see, here, students, it's the first box, right? It's a first box. How many elements we have filled here? N possible ways. It's a second vacant place, second box here. In how many ways we can fill here? N minus 1 ways. Second box, minus 1, right? Here, third vacant place, third box. In how many ways I can fill here? N minus 2. It's a third box, subtract 1, it becomes minus 2, right? Got it now? Now you see, the fourth box, fourth vacant place, I can fill in how many ways? N minus 3. Fourth box, minus 1, becomes 3 here, right? So it is forming a sequence as like this, right? N minus particular vacant place minus 1 there, right? It's a second vacant place, right? N minus second vacant place minus 1, it is 1. It's a third vacant place. N minus third vacant place minus 1, it is a 2. and say n minus, it's the fourth vacant place minus 1. Fine. In the same sense, what is the rth term I can fill here? N minus rth vacant place minus 1. So that it becomes what here? N minus r plus 1. It becomes what here, students? N minus r plus 1. Got it now? So now by the FPC rule, what I have to do? By the FPC rule, I have to do what here? N into n minus 1 into n minus 2 into n minus 3 into so on up to. If you further simplify this, what do you get? N minus r plus 1 value, right? By the FPC rule. So out of n distinct objects, you are forming r number there, r objects you are arranging there. Out of n distinct objects, r number of objects you are arranging at a time. It is given as like this: n into n minus 1 into n minus 2 into n minus 3 into so on up to n minus r plus 1. But sir, it is not giving your formula, sir. Your formula, what you have told, NPR is n factorial divided by n minus r factorial. So nowhere we got this formula here. But we can express further that according to the FPC rule, we got this much as the answer. Out of n distinct objects, I am arranging r number of objects. It is given as like this. Now you see, students. Now you know, you have the idea of factorial form. You have the idea of factorial notation, right? We have the idea of factorial notation. What I do now further, I keep as it is this one here. N minus 1, n minus 2, n minus 3, so on up to n minus r plus 1. N minus r plus 1. Got it? Now you see, students. So next, what we have to do? Next, what we have to follow there? So next, what we have to follow? Just here. Since it is decreasing by 1, students, right? It is decreasing by 1. Now you see, let me decrease this also, students. Let me decrease 1 to this term here. What happens here? What happens? N minus r, right? I'll be decreasing 1 term for this one here. N minus r remains, right? Next, again reduce by 1 now. Again reduce by 1. N minus r minus 1 remains, right? Yes or no? Again you reduce by 1, students. Again you reduce by 1. What happens? N minus r minus 2. Again you reduce by 1. N minus r minus 3. So on up to. I'll be reducing what here? Up till 3 to 1, I'll be reducing there. Up till here you got the answer. By the FPC rule, up till here you got the answer. N minus 1, n minus 2, so on up to n minus r plus 1. So next, further what I did there, n minus, I have reduced the things there. I have reduced the things. So further what I have reduced things here, I have reduced 1 here. What do you get? N minus r. Next again reduced by 1 here. N minus r minus 1. Next n minus r minus 2. So on to n minus, so on up to what here? 3 to 1. So what extra terms I did here? These extra terms I did. So simply I have multiplied this. Simply I can't multiply this. I'll be dividing the same things here. What I have done actually, up till here we got, I have multiplied these terms there. What are the terms I have multiplied there? N minus r minus 1, n minus r minus 2, n minus r minus 3, so on up to 3 to 1. So on up to 3 to 1, 3 into 2 into 1. So now you see, students, if you look at the numerator, now we have product of first n natural numbers here. Now we have the product of first n natural numbers. Now you see 1 into 2 into 3 into so on up to where? N minus 2, n minus 2, n minus 2, n minus 1 into n. So the numerator is nothing but what here? The numerator is nothing but what here? For product of first n natural number, that is nothing but what here? N factorial. See the denominator. So these things I have multiplied in the numerator for the FPC rule there, right? Now what we get? 1 into 2 into 3, so on to last term. What is the last term here? N minus r. So this can be written as n minus r factorial. So out of n distinct objects, if you wish to arrange r number of objects, so this formula you have to remember, students, that to what here? Without repetition. That to what here? Without students. Just until then, you have to remember this formula. So that's why I took one of the example there, PCMB books, right? We have provided, suppose they have provided 4 books, PCMB books. If I want to arrange only 3 books in the shelf, in how many ways I can arrange, students? Now totally there are 4 books. I have to arrange 3 books. So to know the value of this, I have to use this formula. What is the formula? 4 factorial divided by 4 minus 3 divided by 1 factorial, that is 24. In 24 ways you can arrange any 3 books out of 4 books there, right? So starting I gave the example briefly there, right? In the theoretical way I did there, it took more time, right? So to reduce that time, to know how many arrangements we can make, to know that, we use this formula, students, permutation formula, NPR. Out of n objects, I have to arrange r number of objects. It is given as like this. Only this you have to remember today. I'll be giving some more examples based on this tomorrow, and also with repetition formula also it is different one. I'll be explaining and I'll be discussing tomorrow then. Until then, you practice the second exercise problem, students, and have a nice evening there. Okay, thank you one and all.